You know, when we talk about cooking, we usually talk about flavor, right? Salt, fat, acid, heat. But there's a secret engine humming behind the scenes of almost all of our favorite comfort foods. And today we are going deep on that secret engine. We're talking about starch.
I mean, really think about it. What is that thing that makes pasta perfectly tender but not mushy? What gives bread that soft, fluffy texture? And how do you get those ridiculously creamy mashed potatoes instead of, a gluey mess?
Well, it turns out the answer to all of those questions is the exact same thing. And it's probably sitting in your pantry right now. It is, of course, starch. And once you understand the science behind it, oh man, it's like getting the ultimate cheat code for your kitchen.
So let's really get to know this powerhouse molecule. We're about to watch it go through this incredible transformation, all with just a little bit of heat and water. So what even is starch? At its most basic level, it's a complex carb. Think of it like long, long chains of glucose that plants create to store up energy for later. It's why things like potatoes, wheat, and beans are so packed with energy for us. Now here's the important part. These chains are built from two different kinds of molecules, amylose and amylopectin. And the ratio of these two is everything. It's what makes a potato different from a grain of rice. Okay, now for the main event. This is the magic trick. It's a process called gelatinization. Seriously, if you remember one thing, remember this word. It's what happens when you add heat and those little starch granules start soaking up water, swelling up, and creating all those thick, soft, delicious textures we crave. Let's walk through it. If you just toss starch in cold water, nothing really happens. The granules are just kind of floating around. But once you start heating things up, right around 140 degrees Fahrenheit, that's when the magic starts. The granules start absorbing water, and they inflate like thousands of tiny water balloons. And as they swell, the whole liquid around them just transforms into this thick, beautiful gel. This is your gravy getting thick. This is your pasta getting tender. But of course, for every action, there is an equal and opposite reaction, right? The opposite of gelatinization is something called retrogradation. So while cooking with heat makes things soft and thick, cooling things down over time does the reverse. The starch molecules start to tighten back up, they recrystallize, and they literally squeeze water out. This is why food changes so much as it cools.
And this right here, this explains why bread goes stale. It's not just drying out, it's retrogradation. All those starch molecules that were so soft and plump, well, the party's over. They're realigning, getting organized again, and that's what makes the bread feel firm and dry. It's the same reason why leftover rice gets hard and crumbly in the fridge. That's the starch recrystallizing. Okay, enough of the textbook stuff. Let's get into the kitchen. Let's see how all this science actually plays out on your plate with some foods we all know and love. We're gonna start with a classic, pasta. We all want that perfect bite, and now you know the secret, right? It's all about controlling that gelatinization process. So here's the deal. You have to use a ton of boiling water. Why? So the pasta has room to swim around and gelatinize evenly. And that perfect al dente texture you're looking for? That's when the outside of the noodle is fully cooked, but the very, very center is still just a little bit firm. It's only partially gelatinized. If you cook it too long, those starch water balloons we talked about, they burst. Starch goes everywhere, and that's when you get a pot full of gummy, sticky pasta. Nobody wants that. All right, let's move on to potatoes. We have all been there. You set out to make the creamiest, fluffiest mashed potatoes of your life, and you end up with something else entirely. Well, the reason for that comes down to one thing: starch. See, not all potatoes are created equal. You've got your high-starch potatoes, like russets. Their starch granules are big, and when you cook them, they swell up and get super light and fluffy, which is perfect for mashing or baking. On the other hand, you have your low-starch, waxy potatoes like red bliss or fingerlings. Their starch structure is way more compact, so they hold their shape beautifully, which is exactly what you want for roasting or potato salad. And here is the big trap, the number one mistake. If you take those perfect high-starch russets and you overmix them, I'm looking at you, food processor, you physically shred those swollen starch cells. They just rupture, releasing all their sticky, starchy guts. And in a split second, your fluffy, dreamy mash turns into something you could use as wallpaper paste. So please be gentle with your potatoes. Last but not least, let's talk about the star of the bakery, bread. Now, in baking, starch isn't a solo act. It's got a super important partner: gluten. And it's the beautiful partnership between these two that creates the perfect slice. So think of it this way. As the dough bakes, gluten forms this stretchy, elastic web.
but that web is kind of flimsy on its own. It's the starch that comes in and provides the real structure, the scaffolding. As the oven heats up, the starch granules gelatinize, swelling up and filling in all the space in that gluten web, locking everything into place. Then, as it cools, retrogradation starts to kick in. And in this case, it's a good thing. That slow firming process is exactly what creates that tender, chewy crumb that we want in a good loaf of bread.
So there you have it, the secret science that powers so many of our favorite dishes. And now that you know it, you are well on your way to becoming a true starch master. So let's do a super quick recap. Starch is all about transformation with heat and water. Gelatinization is what thickens and softens things, like when you're cooking pasta. Retrogradation is what firms things up, like day-old bread. And maybe most importantly, choosing the right kind of starch for the job is absolutely key. See, when you understand how starch works, you're not just following a recipe anymore. You're conducting a delicious experiment. You now have the power to fix things when they go wrong, to adapt, to perfect your dishes. So the next time you step into your kitchen, I want you to think about the science. What are you going to cook differently?